Hello everyone, welcome to Tech with Machines. Hope you are doing great, and today we are going to do data frame manipulations, the basic structured operations. With this, we will learn different tools which are required to manipulate data within data frames. So as a beginning, we are going to only do basic data frame manipulations and understand and learn them, and followed by we will do aggregations, joins, and also understand those concepts. Today it's going to be more hands-on. We'll directly jump into Jupyter Notebook in a bit, but today's agenda I would like to show. If you are new, it is better you stick with the whole video. If you are already experienced, you can directly jump into the code and try different examples, or maybe refresh your knowledge about these basic operations. So we are going to talk about very basic things today, which will be how to deal with schemas, how to deal with columns, rows, and one of the concepts of partition which helps in increasing or decreasing partitions, which are repartition and coalesce, how we actually do that. So let's jump into the Jupyter Notebook and also understand how we deal with schemas in data frames. So let's start with schemas, and before we jump into schemas, I have created a Spark session. If you're new, then you can follow along. As you can see in line number 2, I have used pyspark.sql module from where I'm importing Spark session, and then using builder I am creating a Spark session. Now today we are going to deal with the JSON data and understand really what schema represents or defines in Spark. Schema generally defines the column names and types of a data frame. Either we define the schema explicitly, or we let the data source define the schema, which is generally called or referenced as schema on read, right? So we are generally going to deal with JSON or CSVs, and I am using a flight summary JSON file, and that you will find in Spark Definitive Guide GitHub link. I'm using mostly the data which is present there. It's a very structured data which you can use to work with Spark and play around with that data. So let's first try to read a JSON file, and now this is important to understand how we are reading the JSON file here. So I am using the Spark sessions read method, and I'm gonna read a JSON format. So generally how we do that is, let me just comment first out here, read a JSON file. So what we are gonna do is, we're gonna first see the explicit schema of that JSON. So what we're gonna do is first read the JSON using the Spark session which we created, and we're gonna say spark.read.format. Currently I have a file called in JSON, so I'm gonna give a format as JSON here, and then we are gonna load that. So I have it in the current directory itself, which is named as 2015 summary.json, and we are gonna say schema of this, and when we run this, generally what will happen is it is going to print the schema of that particular JSON file. So let's see what it prints. So it is printing a data type called struct type, which has list of fields, struct fields, one of being the destination country name of string type, one being origin country name, and another being a long type of count. So a schema is a struct type made up of number of fields, which are generally here struct fields that have and if you see here, struct field has a name, has a data type, and as well as it has a boolean flag which specifies whether the column can contain missing or null values, right? And finally, users can optionally specify associated metadata with that column. So metadata is generally a way of storing information about this column. So schemas can contain other struct types, Spark complex types, which we will go through in coming sessions, but generally this is the overall definition of a schema and how schema looks like, right? So let's say if the types in the data do not match the schema, Spark will generally throw an error. Okay, and now let's see how that really will happen. Let's say I create a manual schema. Now currently here we didn't define a schema, we read it and we just are printing the schema of that particular structure. Let's say we are going to really create a manual schema and then load this file by using that manual schema. So first we will create the manual schema. So let's say I'm calling it JSON schema, and we are going to create it as struct type, and this is the format of struct type. So what we will do is we will create a struct type which can have list of struct fields. So it is going to be a list, and now we create a struct field. So we will say struct field, and first parameter in that struct field is the name. So we are going to give the name as destination country name. Second is the type, and type is generally the string type, so we are going to use string type. But because we are using all these types, we also have to import them. So let's import them first. Maybe I can add a line here and move this from here to here, and we can first import them. So generally we'll use pyspark.sql.types, and from where we will load them. So we are gonna do pyspark.sql.types, and from there we are gonna import string type. We are also gonna use struct field, as you can see, and we are using struct type. So we are gonna load them. Okay, and because one of the columns was a long type as well, so we are gonna use long type as well here. And the last parameter in this is whether it can have missing values or not. So we are saying true, and the other one here, because we didn't load this, the spelling mistake here. So we are gonna say this, and then the second one will be another one which we will use as another struct field, which will be origin country name as name, and then again it's a string type, so the data type of the field, so it's gonna be a string type, and then finally it can have missing or null values, so true. And then the last one is count, which is again a struct field, and we'll use the metadata in this one. So we are gonna say struct field, and we are gonna name it as count, and this is going to be of long type, so we are going to use long type, and we are going to say no, it can't have null or missing values. And then we are also going to give metadata here. So let's say we give metadata as some JSON saying format being true, format being JSON, maybe. Let's give this as a metadata. So we created our first JSON schema. This is how you can create a JSON schema. Now we are going to load the same JSON, but this time we are going to give it a manual schema. So how do we do that? We copy the same thing, we read the JSON format, we load it, but before we load it, we also provide the schema. So we are going to say dot, after giving the format, we are also going to give the schema. So this way we are going to say, okay, I'm going to read it with JSON schema, and let's run it. So it has actually let me try to print it as well. So we are going to print the schema of this data frame, and as you can see, it is basically able to print the schema which we just gave it manually. So this is how you create a schema or you read a schema of a particular data frame, right? So this is all about schemas. Let's move to columns and how we deal with columns and rows. So we dealt with schema, how we define an explicit schema or how we can read a schema. Now we're going to talk about how can we select particular columns from a data frame, and or how can we do SQL select queries equivalent in Spark, right? So we can simply use select function on a data frame and select a particular column and show that and do a show on it. Let's say your simple SQL query was to just help in terms of analogy. Let's say you wanted to fire a select query like select the destination country name from this particular data frame, right? And limit you wanted to put just 2. So if you want to do that, then what you will do is you will say df.select and give the column name. Now there are different ways you can basically give the column name. Now let's say you are using this, and then you will do show 2. So it is gonna show you 2 rows of that particular data frame and the column specifically as destination country name. Now I can also use the call here, the column col method. So what we can do is we can say from pyspark.sql.functions import col, and now if I do the same thing, but this time I don't use the column name directly but instead use it inside the column, it is gonna do the same thing, just a different way of selecting a column. And I will say show 2. So this also did exactly same thing which we just did without referring it inside col, right? So this is how you can select a particular column and show it. Now let's say you want to, now there is another way you can do the same thing, which is called select expression, right? Maybe you want to really rename, or there are 3 ways actually. So one way was that I'm directly using the name of the column in the select, or I'm using col. I can also use column directly, or I can use the expression directly. So how can I do that? Don't get confused if there are if these are too many ways to really select a particular column from a data frame. You can stick to one, but it's better to know all of them. So what we are going to do is we can also use the column method specifically. So let's use the column and not call, and then do the same thing, but just this time we'll not really do it inside the basically we'll really do it inside the column instead of call. So now if you see that this is also doing exactly same thing which we could do with the first 2. Now there is a 4th way which I can select a column, is by using expression function. So we'll use expr and then do exactly same thing, but this time with an expr. So this time we are gonna use select expr, and this is also really listing down the 2 rows of a particular column. So these are the multiple ways you can refer columns in a data frame, and you can use them interchangeably. That's what you have to just keep in mind, but you can stick to only one, but it's different ways of referencing columns in a data frame. So and one more thing is that one common error which is attempted is to mix column objects and strings, but that used to fail in the earlier Spark versions, but that works now. Maybe if I want to use column and the string way of referencing a column, that used to fail in prior versions, but in Spark 2.1 or so this really works, but earlier this used to fail. Now if you okay, I just misspelled the, so you can see that both of them work, and generally it used to fail in the older versions, but this now you can mix them, you can mix the column objects and strings together. So far we have used that 4 ways, and we also saw that expr is the most flexible reference that we can use. We can also really, with expr, we can rename the column. We can actually use an alias for the column, like you want to do name the destination country name as destination, and then what you can do is that you can simply say select expression, and then in expression you can really alias that to destination as destination, and then do a show. So it's a very flexible reference if you want to do that, and you want to change the column name and use it with the as keyword. That's how you can do it with the expr. So this really changes the column name to destination. You can also do other expressions with the expr. Let's go through them in a bit. There is a fifth way also to select a column or reference a column in a data frame. It's just a shorthand of expr. You basically can write it in a more intricate way, is that you do select expr and then generally give that the expression which we use to create an alias, like this, and put it inside this and do the show on that. So this is the fifth way, and this will mostly be used to define the complex expressions if there are any, but these are the 5 ways to generally reference a column. Now let's see about how do we add a column. We are gonna add a literal column to the existing data frame, and that's done using with column. So what we'll do is that we are gonna add a column called with column, and let's say we give the name of the column as a first argument to this particular function, and we are gonna say it as my column, and let's treat it as a literal. So because we want to treat it as a literal, we want to also import one of the functions called let, and give it just a constant like 2. Now what this will do is it's gonna create another column called my column, and let's do show also on this. So this is gonna print all the columns including our new column called my column. Now that's how you add a column to a data frame. Now if I want to drop this column, then there is a method called drop, or remove this column, then it's generally by drop the column. So let's do that. We'll do the drop of the same column, so we'll say drop and then give the column name, which is my column, and then let's print the schema back. So now you can see that column is gone. So that's how you basically add or drop a column in data frame. Now you can also rename a column if you want. There is a method called column renamed. So like you did column addition with column, you can also do a rename column with column renamed. Let's say you want to rename column destination country name with destination, then basically what you will do is you will say with column renamed, and let's use this destination country name inside, and let's rename it to destination and just print the columns for now. So let's try to print this. 1 minute. Okay, I just spelled it wrong. Always a problem. And as you can see, the column name has now been renamed to destination. So that's how you select a column, you add a column, rename a column, or remove a column in data frame. Now let's deal with rows. After column, we will deal with rows. So let's filter a row. Let's say you want to really do a select star from this data frame where the count is less than 2, and you basically want to limit it by 2 rows. You want to get the rows whose count is less than 2, and you want to just get top 2 rows. So what we'll do is we can do it in 2 ways. We can either use a filter method or we can use a where method. So we'll do both. So let's do first filter. So we're going to do df.filter, and then you basically give it refer that column. So let's do this, and then because I want the count to be less than 2, I will do this, and I will try to show them or limit them. So it just gave me 2 rows where the count is less than 2. Let's use where to filter rows. We used filter as a method to filter rows. Now we can use where as well, so that's a different way of filtering the rows. So I can do count is less than 2 and then really do show here and get the rows which have count less than 2. So that's another way of filtering the rows. We can also chain where clause, where method sequentially and do multiple unfilters. Let's say I want to do where column count is less than 2, along with that the destination is not United States. So what we can do is simply chain the another next where clause and give it the column on which we want to do that condition. So in this case it's destination country name, and we don't want it really to be equal to United States, and then let's do the show on this. So this is how we can actually do multiple unfilters together. Now this was about how you can filter rows. Now how can you limit rows? So far we were using show, but show is not really limiting the rows but just showing us the top 2 or top 3 rows. I can also limit the rows and then do a show. So let's say I want to just select 5 rows. So I'll do, this is basically an analogy of select star from this particular data frame limit 5, and then let's do show on this, and you can see only 5 rows of that particular data frame. So that's how you limit the rows. We can also count the distinct rows. So let's say you want to count the distinct rows belonging to a origin country name, distinct origin country name. So what we can do is we can say df.select that particular column. So I'm just going to use the string here. So we'll say origin country name, and we will club select with distinct and do a count on that, which will just print the particular distinct origin country name, so which is 125. We can also really sort or order the rows, for which again there are 2 ways. So I can actually do just sort and do a sort on column count and just do show of top 5, so it's sorting in a natural way. If I want to do descending order, then I can do order by and order them by descending order. So let's do count dot descending and then just do show. Here I'm not doing any limit, so it's giving me all the ones with the count in the descending order. So this is how you can sort or order the rows, limit or do the distinct or filter the rows. Let's talk about repartition and coalesce. What do they really mean, and what are the key differences between them? I have created a video on that as well. You can go through that in my channel. But partitioning is generally an important optimization opportunity, and if you want to partition the data with frequently used or filtered columns, it can basically control the amount of data you are collecting or you are shuffling across the disk, right? Or it can distribute the data equally and uniformly and make it more performant. Repartition, regardless you want it or not, repartition always causes a full shuffle, whereas coalesce generally will not incur a full shuffle, will try to combine partitions. So let's do 2 things. Let's first understand the number of partitions a particular data frame has, and that we can do by doing rdd on that. So we'll say df.rdd.getNum partitions, and this is going to print our current partitions of this particular data frame. So let me correct this. So we are going to say get num partitions, and it's gonna print the number of partitions this particular data frame has, which is only 1. And now let's repartition them. Let's say I want to repartition them and give the number of partitions I want, and I will say df.repartition. I want to give 5 partitions, and now it's gonna create 5 partitions of this data frame. So we are gonna print again the number of partitions and see what value now this is giving. So if you print again, okay, because we didn't really reassign it, so now if you print, it is saying that there are 5 partitions, right? We can also repartition by a column and also give the number of partitions we want. So let's say I want to repartition by a column. So we'll say df.repartition, give the number of partitions I want and the column on which I want to use for partitioning. So let's say we want to use destination country name, and this will basically partition based on that particular column, right? We can also use coalesce, which is basically combining the partition. So let's say we are and this time we are going to reassign so that we know that how many partitions really got combined. So let's say we are doing the same thing which we did in the previous line. We are partitioning it by country name and we are limiting the number of partitions by 5. So this is going to cause a full shuffle, but if we use coalesce on top of it, this will really not incur full shuffle and combine the number of partitions. So now if we run, just 1 minute, what really happened, I have given the wrong name. Okay, and now if we do the same thing and read the number of partitions on that particular data frame, this is gonna really print 2 as the value. So this is how you use repartition and coalesce and optimize the number of partitions the data frame can have, and can do it on a frequently filtered column as well. So that's all about today's session, and I hope you liked this video, and I hope I kept it to the point and gave the basic details of the operations you can use with the data frames. In the next one, we'll talk about aggregations, how you do aggregation and do a simple exercise on aggregations and joins. Please stick to the series